My name is Chad Deters. I'm the chairman of the Kentuckiana Concrete Promotion Group. It's a group here in Louisville that promotes concrete, and right now our biggest push is towards green build and how concrete can help on environmental design, and we've got many ways that we can do that. One of the big areas where concrete is really helping towards the green build movement and lead is the use of insulated concrete forms. Believe it or not, Kentucky is actually one of the leading states in the country right now for ICF, or insulated concrete form construction. The schools are being built all around the state of Kentucky. We're really ahead of the curve as far as green build goes. Is with use of that product. It is very energy efficient. There's actually right now currently a school down in Bowling Green that's going to be the first net zero school in the state of Kentucky, and I think one of the first in the country. It's going to be a very neat project. It's just gotten started.
What's net zero mean?
It's zero carbon.
Okay.
It's had a zero carbon footprint on that building, so they're going to produce as much energy as they use. And one of the big components of that school is insulated concrete forms. And I've got a personal experience with ICFs and insulated concrete forms. I just built my own house, and the energy bills I'm getting on 5,800 square feet of conditioned space are at or below $100, which is I lived in a house in the Highlands before that was 1,300 square feet, and my bills were 200 plus.
Yeah.
So it's very good as far as being able to keep your energy efficiency, being able to keep your costs down. And really the biggest cost, it's all electric, and a lot of the biggest costs are my water heater, and my lighting. So that ICF has really helped add on, and it's really taken off. Here in Louisville, you've got the Home of the Innocents. They really embraced it because they want to, a lot of these places that have got buildings that are going to be there for a long period of time, they're really concerned about long-term operating effects.
Yeah.
Schools they build for 50 to 100 years, and that's the people that are looking for short-term costs. It's going to cost a little bit more up front, but it costs a little bit more.
It's okay. Go ahead.
There's a little bit of investment on the front end, but we're finding Bellarmine University has built all their dorms out of it here recently.
What about the project at U of L? Can you speak on that a little bit?
Well, that's a different avenue where concrete can really help add to the green build. It's a product called Pervious concrete, which allows the water to work its way back into the ground and replenish the aquifer. Which instead of normal concrete, which you think of, which has lots of runoff, and that water ends up in the sewer system, the stormwater system. A lot of times local, like MSD here locally, will actually charge you for that water. We can actually take that water, keep it on site, and actually let it go back into the ground, which it'll actually, while it's going through that, will filter through the pervious concrete and actually clean the water as well. So it'll give you a
he talked about algae inside of the pervious concrete.
There is an algae that actually grows inside of this pervious that allows it to eat a lot of the toxins and the chemicals. I mean, if you're sitting in a parking lot and you look around, all the oils and everything, that it actually will go through that pervious and actually it'll clean that water up.
Wow.
And we've got Pervious at our concrete plant downtown, and in this recent 6.5, 7 inches, however many of inches of rain they finally say we got, it took every drop of it. I mean, no ponding water. It took all of that rain in a short period of time. So it can take the amount of water, and it really helps. Here locally, they've got a real problem with polluted water making it into the Ohio River, and it's just one product that can help. It can help that clean up our rivers.
When was this invented? When was it really invented, and when was it implemented really into more buildings?
Kentucky on some areas, like on the ICFs, we're really ahead of the curve. On Pervious, we're really behind the curve. It really started down in Florida, where they've got sandy soils, and everybody's questions are, will it work on clay soils? Which, as you go further north in some of these really harsh soils, and we're finding that it does. It works, maybe not as well. It won't take as much water, but your typical rain event, it's going to be able to handle no problem. We've got enough applications around the city of Louisville, and they're all performing well. And that leads me in. We're actually working with some people at the University of Louisville right now. I think there are some projects being designed, but the local concrete promotion group that I'm chairman of, we're actually working on a project to donate the pervious and the labor for some concrete on campus.
So it's a donation of
yeah,
kind of
it's an in-kind donation that the concrete industry is going to do. We're actually going to try to make it cardinal red and cardinal black, so to kind of make it fit into campus. And with all the flood damage and all the flooding that happened, it's a little something the campus can do to get rid of some of the impervious surfaces and allow some more of that water to work its way. I know
it's low down there too, so we have a problem with that every time it rains. So
I've talked to a lot of students over there. I actually went and got my master's there, and know a lot of people there that talk about when they walk through campus, they got to pull their legs up when it rains because that water doesn't work its way through. So a project there, we'll put a good stone base underneath it, so we'll actually be able to take quite a bit of water, and students will be able to walk through campus without having to.
Do you know where the location's going to be for it?
It hasn't been decided yet. Right now, they're trying to find out the best location to do it. There's a few areas they're originally looking at. I think the students are going to be involved in actually placing it as well. Some of the students from the engineering department are going to actually be involved in putting it down.
Yeah.
And we've got some local labor and some people that are going to come in to make sure it's done right and bring the equipment and tear out the existing concrete, the existing sidewalks. And it should happen in the next month. I'm talking with a guy right now to help get it organized and make it happen.
Okay, well, I guess that about does it for the questions, and thank you very much for the interview. All right.
Bye.